Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be taking a look at transformation of quadratics. We're going to be finding the properties of a given quadratic function in vertex form, and then we are going to sketch the graph of the quadratic. All right. So let's say we have the function for question number one, y equals 2 times the quantity x minus 1 square minus 2. All right, so instructions are up here. We're going to find the vertex, describe the opening, extrema value, axis of symmetry, we'll find the shifts, and then we'll generate the graph. So let's go ahead and get started with the first part, which is to find the vertex. All right, so what is the vertex of this quadratic function that we have right here? A point to note is that this quadratic form that we have here is the vertex form. All right, because it easily tells us what the vertex is. All right, so the vertex is going to be hk. That's how we determine what the vertex is. All right, so what is hk in this situation that we have here? To determine what hk is, let's go ahead and rewrite the function that we're given, y equals 2 times quantity x minus 1 square minus 2. So we're now going to write down the formula, the general formula for the vertex form of quadratic functions. We're going to place that on top of it, align it in such a way that we can determine what h and k are. All right, so the formula is y equals a times the quantity x minus h square plus k. Okay, all right, so we can easily see what h and k are with this setup. So we're going to extract a, b, h, and k, all right, because a plays a role too. So a in this problem is 2, and then h is basically the opposite of the number next to x. So we have x minus 1, we'll do the opposite. So h is going to be positive 1, all right? And then k is the number that's been added to the squared quantity, all right? So k is negative 2. So something to note, very important, is that when you're looking for that h value, because of this minus is telling you you need to take the opposite, all right? Take the opposite of the number next to the x. So that's why h is 1. You have x minus 1 here, but your h is actually the opposite of minus 1, which is positive 1. All right, so with that in mind, we can easily figure out what the vertex is. The vertex is hk. H is 1, k is negative 2, so our vertex is 1, comma, negative 2. All right, so we have one part down. Now let's go ahead and figure out the next part, which is the opening. So let's alphabetize it. So A is the vertex, B is the opening. How do you find the opening of the parabola? The graph of the related graph of this quadratic function, you simply look at the sine of A. All right, that's what you look at. So what are we saying here with the sign of A? Well, this is a simple rule right here. If A is positive, it's going to be a happy situation. It opens up. And if A is negative, it's going to be a sad situation. The parabola opens downwards. Okay, so basically the sign of A, positive or negative, will tell you the opening. So let's take a look at this particular situation right here. A is 2, which is a positive value. So that tells us that the parabola is going to open up. All right, so let's write that down. So this parabola opens up. Why? It opens up like this, bam, because or since A is equal to 2, which is positive. Okay, so that's the justification for why it opens up. A is equal to 2, which is positive. So if it's positive, it opens up. All right, just like happiness for positivity and sadness for negativity. All right, so that's how you can look at it. All right, so we have it opening down. Let's move on to the extrema in value. All right, extrema in value. So the extrema is basically the extreme. What's the nature of the extreme? All right, so for the extrema value, it's going to either be a mean or max, either minimum for opening up or maximum for opening down. And it's going to happen, the value is going to be the value of the extrema is y equals k, and it happens at x equals h. Okay, so the value is y equals k happening at um, x equals h. You see how important the vertex is, right? Tells us so much. So in this particular situation, it opens up. So since it opens up, we automatically know what the nature of this extrema is. If it opens up, you have a low point right here, which is the minimum. So for part C, we have a minimum as the extrema. All right, so we have the minimum, smallest value, minimum value of what? Y equals the k value, which is -2, and it happens at the h value of your vertex, which is +1. Okay? All right, now next thing we need is the axis of symmetry and the shifts. So for part D, let's find out what the axis of symmetry is. It's that vertical line that divides the graph into two identical parts, axis of symmetry. The nice thing about this is that the axis of symmetry goes right through the vertex, okay? So it's simply x equals h, the h component of your vertex, the x component of your vertex. So what is the x component of the vertex? Is 1, right? So our axis of symmetry is simply going to be x equals 1. The last property we're going to find before we generate the graph of this quadratic function are the shifts. Okay, so what are our shifts here? Our shifts are basically the h and k values. So the shifts are h units to the left or right, and then k units up or down. Okay, so positive, so we have a positive h value is going to go to the right. If it's negative, goes down. If you have a positive k value up, negative goes down. All right. So what do we have here? If you take a look at the vertex, +1 for the x value. So that means we're going to shift to the right 1 unit and then down -2 because our k value is negative. So what are our shifts? You're going to shift 1 unit to the right, okay, and 2 units down. That's where the location of our vertex will be. Okay, so let's go ahead and generate a table. We're going to graph now, last part. So to graph this, we're going to generate a table of values for this. So let's create our chart. So we have our x, okay, and then we have the function y equals 2 quantity x minus 1 square minus 2. So we're going to just use 3 points to sketch. It's just a sketch of our quadratic function of parabola. All right. So what we're going to do is we're going to place the vertex, very important, at the center. Center the vertex. Our vertex is 1, -2. So put a 1 here for our x coordinate. And then what is the number before and after 1 on the number line? Before 1 is 0, and after 1 is 2. So we're going to input these two values into the quadratic function to determine what the outputs are going to be. All right, let's start with 0. So we're going to figure out what y of 0 is. So y of 0 is going to be 2 times 0 minus 1 quantity square minus 2. We're now simply going to use PEMDAS to simplify this expression. So the right side of the equation. So now for that, we have parentheses and an exponent, multiplication, and a subtraction. So we're going to do the parentheses first. 0 minus 1 is negative 1. Square minus 2. So following PEMDAS, exponent is next. So negative 1 square is just 1. All right, because minus times minus is plus. So 2 times positive 1 minus 2. Okay, and then you multiply, you get 2 minus 2. And your answer is going to be 0. All right, so that is our output value for the first input of 0. Okay. All right. Now let's take a look at the second one. So the second one, x equals 1. Well, we already know from the vertex here that when x is 1, y is negative 2. So we don't have to do any work here. Let's put a happy face to reflect our joy that we don't have to do anything to determine what that output value is. Just we're basically taking the vertex and sticking it right here. Okay. All right, now, but the one after, we're going to actually have to do some work. So y of 2. Now, this is an important part where you're going to have to check the accuracy of your work. Since this is the line of symmetry, the output before and after the vertex, since as long as it's the same unit apart, 1 unit before, 1 unit after, these two must be the same. So this has to be 0 or else something is wrong, okay? All right, so let's work it out. Plug in 2 into the function. 2 times 2 minus 1 square minus 2. Now we're going to use PEMDAS to simplify this. Parenthesis first. 2 minus 1 is 1 square minus 2. Okay. Exponent next. 1 square is just 1, so it's 2 times 1 minus 2. Multiply next. 2 times 1 is 2. 2 minus 2 is 0. Voila, that's exactly what we want. So these are our y coordinates for the table. Okay, so I'm going to just compress it and place them right here. So it's easy to see exactly what's going on. So what we're going to be graphing are the three coordinate pairs, 0, 0, 1, negative 2, and 2, 0. Okay, so these are the points that we're going to use. Our vertex is to the right and then down. That's centered at quadrant 4. So we're going to make quadrant 4 the center of action, make it pretty big. So let's go ahead and graph our points. So we're going as low as 2, 2. So for the x, we're going from 0 to 2. For the y, 0 to negative 2. All right, so let's do this. 1, 2, 1, 2. All right, let's graph our points. So we have 0, 0 right here, the origin. 1, negative 2, 1, negative 2 right here. And then 2, 0 right here. Bam. So these are the 3 points that define our parabola. Let's go ahead and graph it. All right, so there goes our graph right there. So we're gonna also just put in some labels. We're gonna put in the axis of symmetry. Let's make that blue. No, let's make it red. So the axis of symmetry is that line that goes right there through the center of the graph. Okay, so if we label that, this is the axis of symmetry. The axis of symmetry is x equals 1, and that harmonizes with what we have here, x equals 1 as the axis of symmetry. This point, that's our vertex. See this point right here? That's our vertex of 1, negative 2. Okay, let's put the numbers in. So this is 1 right here, this is negative 1, and this is negative 2. And then when you trace it out, this is a low point. You can clearly see that this is a minimum because it's a valley, it's a low point. So we have a minimum value of y equals -2. And you see where it happens at? It happens at x equals 1. Agrees perfectly with what we indicated here. All right, so there goes the graph. All right, so to wrap things up, we're gonna go ahead and check our work using Desmos. So we're gonna input this function into Desmos and see if it agrees with what we have here. So let's launch Desmos. Go to desmos.com to start your graphing calculator. We're gonna go ahead and enter the function. So we have y on the let's make this a little bit smaller. On the left, on the left field right here, that's what we are entering. So y equals there goes a problem right there, 2 times the quantity x minus 1. Okay, close that. To access the exponential field, you're just going to use shift 6 to get the caret, and then square minus 2. Bam. All right, so there goes the graph that we have right there. Zoom in a little bit. Does that agree with what we have over here? Let's mark the points. Bam. So C1 -2 is our vertex. Excellent job. And we have a point here, 2, 0. And we have another point here, 0, 0. So these are exactly the points that we have on our table. You see how we have 0, 0 for the first point? Okay, 1, -2, that's our vertex, as you can see here. And then 2, 0 is the other point. On the other side of your axis of symmetry, equidistance from 0, 0 to the right. So this clearly shows that our answer is in fact correct. Thanks so much for taking the time to watch this presentation. Don't forget to help support our channel with your likes. If you have any questions or comments, specify in the comment section below. Tons of support resources can be found at mathgotserved.com. Do check it out. Thanks again for watching, and we'll see you in the next video. Goodbye.